Welcome to BVS Pragati channel. In this session, let's have a look at resonant circuits. So what are resonant circuits? Resonant circuits are those which show maximum voltage or current at a particular frequency of excitation. So here is a series resonant circuit where the resistance R, L and C are connected in series with the source. So R, L and C are connected in series with the source. Z equals to, the impedance is R plus j omega L minus j by omega C. So what is current? Current is V by Z. So at resonance what happens? The impedance become resistive. The reactive components cancel each other. So j omega L will become equal to j by omega C. So they cancel each other. At resonance, impedance is minimum and current is maximum. Series resonant circuit is also called acceptor circuit or voltage resonant circuit. Series resonant circuit is a voltage magnifier. An alternating current circuit, series resonant circuit, is said to be in resonance when the applied voltage, and the resulting current are in phase. Below resonance, current is leading, voltage is lagging. Above resonance, current is lagging, voltage is leading. 3 dB points are F1 and F2. At frequency, XL equals to XC. It is a frequency at which phase between voltage and current of inductor and capacitor is 0. F0 is 1 by 2 pi root LC. Bandwidth is R by 2 pi L in series resonant circuit. At resonance, power factor cos pi is equal to 1. At 3 dB points F1 and F2, current is I by root 2. So at F0 it is I, at here it is I by root 2, here it is I by root 2, that is E by R root 2. So impedance at half power point is R root 2. Let's see how it is. So impedance at half power points is Z is R plus minus JR. At F1 it is R minus JR, at F2 it is R plus JR. So when you take the magnitude, it is root of R square plus R square. So that is how it is R root 2. Tan theta is equal to JR by R. So that's how phase angle is 45 degrees. Cos pi is 1 by root 2 and power factor at F1 and F2 is 1 by root 2. Power becomes half at F1 and F2. Okay. Now let's go ahead and see some more properties. So what is the bandwidth? F2 minus F1. So what is a parallel resonant circuit? Parallel resonant circuit is a rejector circuit, current magnifier, anti-resonant circuit. It is also called a tank circuit or a tune circuit. Here is a parallel resonant circuit in which the inductor, capacitor and resistor are connected in parallel with the source. So below F0, inductance is leading, that is current is lagging. Above F0, capacitance is leading, that is current is leading. At F0, Z is R. So here in parallel resonant circuit, Z is maximum, so current is minimum. I is equal to V by R, current is minimum. When L and C get connected in parallel, at F0, Z is infinity, I is 0, it is called rejector circuit. When L and C get connected in series, at F0, when R is not there, Z is 0, I is infinity. So this is called acceptor circuit. Parallel resonant circuit is called anti-resonant circuit because current is minimum at resonance. Let's have a look at some more properties of parallel resonant circuit. At half power points, resistance decreases by root 2 times. So in series resonant circuit, it was R root 2. Here it is R by root 2. So current is increased by root 2 times. So here it is minimum. Here current increases by root 2 times, I root 2. Power factor is unity. Current magnification is Q times the applied current. Susceptance is equal to conductance at half power points. At half power points, in series resonant circuit, magnitude of reactance component Z is equal to resistance component. Current in parallel resonant circuit is VCR by L. So let's discuss about the properties of series resonant circuit. At F0, what we have seen, Z is R min. So since Z is R min, what happens? Current becomes I maximum, which is equal to E by R min. Pi is 0. So cos pi is 1. What is F naught? F naught is 1 by 2 pi root LC. We have seen that series resonance circuit. In series resonance circuit, voltage magnification is taking place. So EL is Q into E. EC is Q into E. So quality factor Q is omega naught L by R. Q naught is 1 by omega CR. Now at F1 or F2, that is at half power point, Z is R root 2. I is equal to I by root 2. What is pi? Pi is 45 degrees. Cos pi is 1 by root 2. Z is R plus minus JR. What is the bandwidth? In which ways? It is F2 minus F1, which is equal to F naught by Q. This is all about series resonance circuits. Now let's have a look at the properties of parallel resonant circuit. So in a parallel resonant circuit, we have seen at F naught, Z is R maximum. So what happens? Current becomes minimum. E by R max. So current is minimum. Pi is 0, cos pi is 1. Quantity factor is R by omega L, which is equal to omega CR. So in parallel resonance circuit, what happens? Current magnification happens. So Q into I. F1 or F2, impedance is R by root 2. I is I root 2. And the admittance is G plus minus J, G. Conductance and susceptance. Pi is 45 degrees. Okay. Cos pi is 1 by root 2, which is equal to 0.707. The bandwidth is F naught by Q. So that's all for this session. More in the next session. Thank you. Thanks a lot and I wish you all the best.